Dear students, today let's discuss about frictional mechanics. The name itself implies the friction, also we call the frictional force, is a force which opposes the motion of a body or tendency of a body to move. For example, the friction is generally divided into two types. First one is wet friction and the other is dry friction. If we consider wet friction, one is wet friction and the other is dry friction. These are two types of friction which we generally observe. Let's discuss detail about wet friction and dry friction. Firstly, if you see this wet friction, the friction which arises, the opposition which arises due to the collision of the medium particles, with the body is called the wet friction. For example, we can observe, for example, the best example for wet friction is air friction. The example for wet friction is air friction. If we know that what happens in air friction, actually happens in air friction. For example, if you're moving on a vehicle, if I am moving on a vehicle, the air which opposes the air molecules, we can observe that the air opposes the motion of the body. So what actually happens is that the air, which is a mixture of gases, is made up of molecules, right? The molecules collide with the body and on which we move, that is our body, and therefore we can feel the opposition created by the air. Such forces which opposes the motion of the body by the collision of the medium particles is called the wet friction. Whereas if we consider about this dry friction, the dry friction arises due to the irregularities in the surfaces in contact. For example, if I'm having a body placed of mass m placed on a surface, then here it looks like this. But if I see a microscopic part here, okay, if I consider a small circular part which is a contact surface between the body block and the surface, if I see this surface under a microscope, it looks like this. This is a surface, okay, the surface taken, and this tells you about the upper surface and this tells you about the lower surface. Okay, now you can observe here that the upper surface and lower surface, you can observe the irregularities in contact, and here the contact force looks like this, perpendicular to the surface in contact. And now you can observe due to irregularities, it has two components. One is the horizontal and the other is normal. This, for example, the normal force, which is called as normal reaction, whereas the horizontal component we generally call it friction, and the resultant of all these forces, both the forces, which can be given by square root of n square plus f square, is generally called as contact force CF. So therefore, if we consider this, let us discuss about this contact force and frictional force and horizontal force, normal reaction, everything in detail later. But as of now, the basic notion of dry friction is that the frictional force which created due to the irregularities in surfaces in contact is called the dry friction. Now let's discuss in this topic, in frictional mechanics, let's discuss just only about the dry friction, and later on in my fluid mechanics we can discuss about this wet friction. So let's continue next sheet. So as I just said you regarding this about the frictional force and dry friction, now let's discuss about this dry friction in detail. Okay, dry friction. See, dear students, the dry friction, as I said, it arises due to the surfaces, due to the contact in irregularities in the surfaces in contact. Now what actually happens? What is frictional force? What is normal reaction? And what is the contact force? Let us discuss about the normal reaction, the contact force, and the frictional force in detail. Firstly, contact force. For example, if I consider a block of mass m placed on a surface, then as we know that the weight acts vertically downwards, whereas the normal reaction will act vertically upward if the surface is smooth. What do we mean by the surface is smooth is that there is no rough surface, that is there is no frictional force arising. there is just only one force, that is called normal reaction, and that is perpendicular to the surfaces in contact. And as according to Newton's third law, normal reaction will be generally equal to the weight of the block mg. And now, dear students, if the surface is rough, then let's discuss about it's the same concept with surface in rough. For example, let's consider the same block placed on a rough surface instead of a smooth surface, and let an external force of F is applied. F external is applied on the block. Now, dear students, let the weight acts vertically downwards, as I said, and what we call this contact force will be inclined at some angle with the horizontal, and let the angle be theta, or let the angle made by the contact force with the normal reaction n, let it be theta. Then this theta is called as the angle between the contact force Cf and the normal reaction n. When generally we call this angle theta as angle of friction, and the contact force is having two components, one what we call as normal reaction, and other we call as the frictional force. So the contact force Cf can be given as the resultant of normal reaction plus frictional force, and as I said, the theta here, which implies this theta, which tells you about which gives you the angle between the contact force and normal reaction, is called the angle of friction. What do you call it? Angle of friction. So as I said, this is called angle of friction, and this is called contact force. Therefore, finally, if we consider this normal reaction, contact force and frictional force, these three are nothing but the normal reaction and the frictional force, both are the resultant of the contact force. I hope so the students are understanding, right? If any doubts, please ask me without fail, okay? Please ask me without fail, okay? Now let's discuss about this angle of friction. Let the angle be theta, then the tan theta, from this figure you can observe that tan theta is equal to the frictional force F by N. Therefore theta is equal to tan inverse F by N. This theta is called as angle of friction. Okay, that is about angle of friction. And now, dear students, let's discuss about the types of dry frictional force and how they vary, and what is the graphical structure and graphical analysis of all this frictional force in the next sheet. These concepts are generally considered to be very important for the students who are preparing for the engineering mechanics in the classes +1, +2, and also in BTech first year and second year. And now, okay, let's discuss about the different types of dry frictional force that are available. Dry frictional force, as I said, this is basically arised due to the irregularities in the surfaces and contact. Actually, this dry frictional force is generally divided into three types. One is static frictional force, the other is kinetic frictional force, and the other is rolling frictional force. Okay, static frictional force, kinetic frictional force, and rolling frictional force. I will discuss about rolling frictional force in the rigid body dynamics, rigid body RGB, rigid body dynamics में मैं इसके बारे में बात करूँगा. अभी मैं static friction और kinetic friction के बारे में I will tell you something. Okay, let's discuss about the static frictional force and kinetic frictional force. What is static frictional force? The name itself implies the frictional force which acts when the body is at rest. Therefore, that is what we call the static frictional force. And kinetic frictional force is that which acts when the body is in motion. Okay, therefore that is the difference between static frictional force and kinetic frictional force. Let's discuss about them in detail. For example, I am having a body of mass m placed on a rough surface. Okay, rough surface. Let the external force F external is applied on the body. And now we know that we can, in general observation and daily observation, we can observe that, for example, if I place a book, okay, if I place a book on a table and if I apply the minimum force, it cannot move. When you go on increasing the force, okay, at some instant it starts moving, right? Therefore, at the point at which it is about to start, Till then, the frictional force which is acting, which is opposing the external force you applied, is called the static frictional force. And once the after the motion starts, and when the body is just about to move, that is at that instant about to fly, what we call at the time of movement, about to move, the frictional force which is acting is called the limiting frictional force. And once after starting of the motion, after the body starts moving with some velocity, with an accelerating force, okay, then we say that the frictional force then acting is called the kinetic frictional force. And let's discuss about the analytically regarding the frictional force, static frictional force, and an mathematical expression regarding the frictional force. Okay, as I said, the weight mg acts vertically downward, and the normal reaction n will be acting vertically upward. Some experiments were done regarding the experimental and mathematical equation which represents the static frictional force and kinetic frictional force. And the static frictional force, for example, let's see some examples, some experiments. For example, if I'm having a block of mass m1, another block of mass m2 placed one above the other, we can observe that in our house, if there are a bunch of books placed one above the other, and if you want to move all the books, the force should be applied is more when compared to the move a one book which is kept on the same table, right? If there are about 2 or 3 books placed one above the other, the force required will be more when compared to the only single book, right? So what we say there is that the frictional force that is being increased will be directly proportional to the normal reaction. The proportionality constant is called mu, and what we call by this mu is called frictional coefficient. What we call this? Frictional coefficient. This is called frictional coefficient. This is of 3 types: static coefficient, kinetic coefficient, and rolling coefficient. Generally, static coefficient will be greater than kinetic coefficient when compared to the rolling coefficient. All these experimental notions will be discussed by me later. Okay, now this equation f is equal to mu n will tell you regarding the algebraic mathematical equation of a static frictional force. Now let's discuss about the static frictional force in detail in a graphical notion. Now dear students, let's discuss here on graphical notion. Graphical analysis of static frictional force. What actually happens? Let's discuss about this graphical analysis. For example, if I draw a graph taking the external force applied F external on the x-axis and the frictional force that is being developed on the y-axis, you see dear students, what actually happens is when the external force is 0, the frictional force will be 0, and when you go on increasing the external force, the frictional force also increases. At some instant, ultimately what actually happens is that at some instant, finally the frictional force, the external force will be reaching its limiting frictional force. Okay, till then it continuously increases with an angle theta, and this frictional force will reach its limiting frictional force. Once after reaching the frictional force, reaching this limiting frictional force, the particle starts moving, and after the particle starts moving, the static friction turns into kinetic friction, and there will be generally decrease in the graphical curve, and it looks like this, and later it remains constant. The decrease in the curve, tangent slope of the curve implies that the coefficient of friction has changed from mu s to mu k, which implies that there is a decrease in the frictional force. Okay, that is what actually happens. And you can observe that, for example, you can generally observe when you start cycling a bicycle, right? For example, if you're moving on a bicycle, and if you just want to start the bicycle, you should apply the force should be applied will be more when compared to that. Once it starts, it will be moving easily, right? Therefore the force required will be more when compared to Fs, will be more when compared to that of Fk. Okay, therefore finally what I can say is that Fs will be greater than Fk. And now let's discuss this tells you about the graphical notion of the frictional force. This concepts of will give you the basic notion regarding the frictional force. Let's discuss in detailed experimental analysis regarding this graphical analysis regarding this static frictional force, kinetic frictional force, and rolling frictional force. Okay, dear students, now let's discuss about the static frictional force. Okay, um, for example, I will give you some examples regarding this static frictional force, and you can observe, you can get some detailed understanding. Okay, for example, if someone asks you, you are being given a block placed on a table, a rough table of frictional coefficient mu. Okay, and instead of applying the external force horizontally, you are being given a force which is being applied at some inclined angle at an angle f, at an angle theta. Then you are being asked what is the minimum force required to move the block. Okay, that's the question being put forward for you, and let's discuss how to get the minimum force required to move the block. You see, dear students, this force F is being acting on the block at an angle inclination. Let the inclination angle be theta. Then it will have two components. One is the horizontal and the other is the vertical component. Let's see the components. One will be F cos theta, and what will be the other? The other will be F sin theta, which will be acting in vertically upward direction, and the weight of the block will be acting in downward direction, and normal reaction will be acting in upward direction, and the frictional force will be acting in backward direction. What do we mean by the minimum force required to move? The minimum force required to move is the force which required to move the body with uniform velocity or just about to move. Okay, there is no necessity of the body to accelerate. Okay, therefore finally what I can say is, whatever the maximum limiting frictional force that is created, if the same amount of external force is applied, if it is applied, then it is enough to move the block. Okay, that is the minimum force, and if you apply the more force than this, the block just accelerates. Okay, and you are being asked for an external force, which is the minimum external force required to start the block to move, right? Therefore it will be just equal to the limiting frictional force. Okay, as I said, it will have F cos theta and F sin theta as two components. And see, dear students, if I see the vertical equilibrium, what I can write from that? From vertical equilibrium, n plus F sin theta should be is equal to the weight of the block mg. From this, what can I write? Normal reaction mg minus F sin theta. What is this? This is the normal reaction acting on the block. And you see, dear students, what is the horizontal component acting? F cos theta, just F cos theta is acting. And what is the in left direction? It is friction F. What is friction? Is nothing but mu into normal reaction, and as we calculated, normal reaction is equal to mg minus F sin theta. If we substitute this here, what will be this? F cos theta is equal to mu into normal reaction is mg minus F sin theta, right? Mg minus F sin theta. From this, what I can write? F cos theta is equal to mu mg minus mu F sin theta, right? From this, if I take this F sin mu F sin theta this way, what will be this now? F of cos theta plus mu sin theta will be equal to the mu mg, right? From this, what is the force? F mu mg by cos theta plus mu sin theta, right? What we have did, what we have done, you see, this n plus m sin theta, that is vertical component, should be equal to the weight of the block. Normal reaction is equal to mg minus F sin theta. F cos theta is equal to mu into normal reaction. From this, I solved the problem and I got the external force F to be applied. It will be equal to mu mg by cos theta plus mu sin theta, right? Let's continue on next sheet. Okay, now you see, these students, what did you get? F is equal to mu mg by cos theta plus mu sin theta, right? Okay, dear students, if you see this mu mg by cos theta plus mu sin theta, as we know, numerator by denominator, for F to be minimum, this is the external force F. For F to be minimum, the denominator should be maximum. What is the denominator? Cos theta plus mu sin theta. This should be maximum. What I want to do is that